This is 3.6, review number 2. This is problem number 4. So we have a right triangle, has legs of length 2.7 and 3.6. Longer leg is increasing and the shorter leg is increasing. So both of those are increasing, which tells me that my triangle does not have a constant size. So here is my triangle. We draw this out as we've typically always done. All right, we have our y, we have your x, you have your r. This is a right triangle. So remember it says longer leg is increasing at a rate. Whenever you see the word rate, rate always means that you have a d something, it's a derivative. So it says the longer leg is increasing at a rate of 7 feet per minute and the shorter leg is increasing at a rate of 6.5 feet per minute. So we have to figure out which one's the longer one and which one's the shorter one. And what we've done in class is the y has always been the shorter one, so I'll just continue with that. So it says here the legs have length of 2.7 and 3.6. So the 2.7 is going to be the shorter one over there on the y, and the 3.6 is going to be down here on the x. Technically, it doesn't matter if you have it reversed. All right, if you have to pick one, that's how I'll solve this problem. So longer leg, that would be the x then, is increasing at a rate of 7 feet per minute. So dx over dt here is equal to 7. And then the shorter side, which is the y, is increasing at 6.5. So dy over dt is equal to 6.5. All right, and it says how fast is the hypotenuse changing at this instant? And then there's a part B, how fast is the angle between the shorter side and the hypotenuse changing? So first, part A here, when we're solving for the dr dt, which is how long or how fast the hypotenuse is changing, we're going to have x squared plus y squared equals r squared. Again, if you were given a constant, you would plug that into this formula so you could replace one of the letters. There is not a constant here. So when I solve this, I'm going to do my derivative. It's 2x dx dt plus 2y dy dt equals 2r dr dt. Then you're going to plug in the information that they give you. After the derivative, you plug in. This is 2 times by x is 3.6, times by dx dt, which is 7, plus 2 times by y, which is 2.7, times by my dy dt, which is 6.5. This is equal to 2 times by r. Well, I don't have r right now. So what we've always said is when you're missing something, you go back to the original equation. So I'm going to do that. This is the x squared plus y squared equals r squared. And I'm going to plug in the 3.6 squared plus now my 2.7 squared, and that's going to equal to the r squared. You solve this for r, and you get r there is equal to 4.5. So I'm going to replace that for my r in my derivatives. This is going to be 4.5 times by my dr over dt. You simplify the left side and you divide off by the right side, which in this case would be 9, and you get your dr over dt here is going to equal to 9.5, and that is feet per minute. So that is part A. For part B, do that down over here. Part B, it says how fast is the angle between the shorter side, well the shorter side here is y, and the hypotenuse changes. That's looking for this one up here. So there's my theta. So when I go through and solve this, I'm going to take my derivative after I find my trig function. All right, so which trig function are you going to use? You can see I already wrote tangent down because I'm going to use the x and the y because I'm given dx dt and dy dt. Although I just solved for dr dt, that could possibly be wrong. I'm going to use the information they give us. So this is tangent of theta is equal to the opposite, which in this case is x, over the y. You're going to rewrite this as tangent of theta is equal to x times by y to the -1. And now we're going to go through and solve for our derivative. And when we solve for our derivative here, we're going to have secant squared of theta d theta over dt for the left side is equal to, the right side is a little more complicated because you have to plug in, you have to follow the product rule. So derivative of the first, the x is just going to be dx dt times by the y to the -1, and then it's going to be plus, leave the x alone, times by -1y to the -2nd dy dt. All right, at this point, we're going to take all the information and plug it in. On the right side here, we have all the information given to us here, what I have written out in pink. All right, on the left side, we go to start to fill this in. We have secant squared of theta. Well, we don't have theta. So again, just like prior, when you're missing something, you go back to the original equation. In this case, the tangent of xy. All right, so tangent of theta is equal to the x was 3.6 over my y, which is 2.7. You're going to solve this by doing tan -1 on both sides. That cancels on the left side, so you have tan -1 of 3.6 divided by 2.7. That comes out as 0.927. So here I have secant squared of 0.927 d theta over dt is equal to, now I'm going to do the right side. Dx dt again was 7 times by y is 2.7 to the -1 plus the x now, my x was given to me as 3.6 times by -1 times by that y to the -2. So y here is 2.7 to the -2nd. And then times by my dy dt, which is 6.5. All right, so when you simplify this all out, I would do the right side first, get that on my calculator, and then you're going to multiply that by cosine squared. Remember, when you have secant squared, you really want to take the right side here and divide by secant squared. But since there's no secant button on the calculator, you have to do this a little bit different. We're going to multiply by cosine squared, because this is, secant squared is 1 over cosine squared. So if you multiply the right side that you have right here on the calculator by cosine squared, remember when you type it in, it has to be parenthesis, cosine, 0.927, and the parenthesis for the 0.927, and the parenthesis for the cosine, and then square. When you do that, you solve, you get your d theta over dt here is going to equal to -0.222 radians per minute.